But okay, if you do me a single favor, please, and go to, let me move this one here. Okay, if you guys go to chapter 3, please. Chapter 3 talks about luminaires. Luminaires is a fancy name for a lighting fixture right above Adam's head, right here. You're looking at it. So this chapter, guys, if you guys remember the first two chapters in this book, the first one talked about the nature of light, and we talked about the visible spectrum and what's not. The second one talks about the sources of light, which is all these fluorescent lights and high intensity discharge lights and LEDs and what's not, and how do they work and how do they function. So we talked about the nature of light, then the sources of light. Now this chapter, chapter 3, talks about luminaires. Luminaires, like I said, is a fancy name to describe a lighting source properly situated in a box, basically, to deliver the function of that lighting source, which is light, right? That's what a luminaire is. So let's talk a little bit about this thing, guys. The first thing you need to know about luminaire, and these are PDF'd. I pulled this information, guys, directly from the book. They're PDF'd, and they will be on the network for you to summarize the chapter. Does that make sense? So what I have for you for example, luminaires right above your head. When we talk about luminaires, guys, it's a lighting fixture. So what does a lighting fixture do for a living? What is it made of? The first and the most important thing, guys, has a housing. Can you put UL in OSHA? UL will not give you a label or a list for a lighting fixture, guys, hanging, that lighting source just hanging up in the air like this. And if you talk to creative people like my friend Adam, you can create any type of lighting fixture that has no UL listing. To get the fixture to be safe and fully protected, guys, from shock hazard and fire hazard. We have the shock hazard, shocking people, killing them. We have fire hazard, creating a fire that burn the whole building, right? And we have arc flash that can burn people as they work on equipment. All this to protect the people from a lighting fixture. The smart of the chat decided we're going to put it in a house. You're looking at it right there. So they put it in typically metallic boxes, though they have non-metallic box. They stick the lighting source in a house. So the most important part of a luminaire, guys, is a housing. They call it the housing. The housing is where everything is housed in order to make that luminaire. You're looking at it right there. Okay, what's the function of housing? Why do we have housing? Protect the fixture itself, as well as protect the building from fire and the people from being shocked. Very simple. Protect the people from being shocked, the building from catching fire if there's a fire in this fixture, and the fixture itself protecting it from people accidentally damaging things inside that fixture. So that's your housing. Now we got the housing. Inside your housing, the most important thing inside your house, I'm going to jump to 1 to 4, guys. Number 4. So I'm jumping from, here's my number 1 here. Let me put a dot here. Number 1 all the way to number 4. Inside your housing, there is very single important thing inside that box. It's called a lamp. That's why it's called a lighting fixture, because it creates artificial light for us. Lamps. I'm not going to go through the lamps, guys, again. Chapter 2 talks about different type of lamps. Inside it, you can have incandescent lamps. Kiss this one goodbye, because commercial industrial building, you don't meet the energy code for the incandescent. You have a fluorescent light that's still used and respected fixture right above your head. You can have high intensity discharge light, induction light, or LED light. These are the different type of sources of light that you can stick inside a box and call it a luminaire. Does that make sense, guys? The most common ones right now that we're using fluorescent, we're using high intensity discharge, like mineral halide and high pressure sodium, as well as LEDs. These are the most common 3 sources of light, indoor, outdoor. LEDs are invading the industry. Fluorescent are still well respected, as well as high intensity discharge for outdoor, still well respected. Okay, so why do we have all these lights, guys? We have them for one reason. As the lamps, when we have the lamp, it's the source of the light, the artificial source of light. Otherwise, if you can channel the Lord's light, which is the sun, right, at night, somehow, can you imagine if somebody come up with a mechanism and putting a big mirror right in the space and reflect the light in certain areas? Can you envision this one? Then we don't have lights, we don't have nights. Who wants to live like this, though? So at one time, maybe Brian will come up with a mechanism instead of a satellite dish sitting in the space, or satellite, what do you call these? Yeah, a satellite sitting in the space. You'll have a big mirror that reflect the light and make North America light all the time. Could happen. So anyway, until that point, we need light at night and even during the day. So here's all your sources of light. So that's number two. In order for the light to work, guys, they have something called ballast or a driver. Anybody knows what the ballast or a driver is? If it's high intensity discharge or low intensity discharge, if it's fluorescent light like the one above your head, or high intensity discharge like mercury, we don't use mercury, metal halide, high pressure sodium, you need to have a ballast. What the job of the ballast is two functions. A big box, you bring the voltage 120 or 277 here, it pumps it so high up to say 2000 volt to start the arc, pump the voltage so high to start the arc or through pulsation and what's not. Now we start an arc, and when the arc is there, it chokes the current because the arc guys create a lot of current. If a lot of current start going through the circuit, guess what? The circuit breaker will wake up and say, you're crazy, you're having a short circuit here, trips. So it pumps the voltage high to start the arc, and it chokes the current to maintain the arc, choke it down, it lower it below the level of the circuit breaker waking up. Welcome to your ballast. That's what your ballast is going to do, guys, for your high intensity discharge as well as for fluorescent lights. Now LEDs, instead of a ballast for LED, Adam, they don't call them ballast. They call them driver. Now what the heck is a driver? A driver, it takes the 120 or 277 here, guys, and from the other end, it converts it to 24 volt DC and burn all these LEDs. Burns them at 24 volt DC or whatever voltage they're using. Does that make sense? You take 277 here, from this side, you take 24 volt DC, and you burn all these LED lights at them. So in order to have an LED fixture, always think, Karen, that you need a driver. You need a driver, they call it driver. A driver is like a ballast except for the LEDs. So get used to the term driver. Okay, so now we have a housing. Inside it, there is a lamp, and inside the lamp, there is a ballast that can drive the ballast, which is either a ballast or a driver to drive and maintain the arc or the LEDs. The third thing, guys, I'm going to focus in is power connection. Now we look at this fixture, guys. You need to have a little box there with a knockout where you bring your MC cable to a location where you can tie to the ballast, right? That's called power connection box. Either a box or some type of an enclosure inside that fixture, Brian, where here's my fixture, my luminaire. I bring my MC cable in through a knockout, properly connect through the knockout with MC cable. Inside, you'll have a little enclosure where you tie to the fixture wires inside the fixture, right? That's how the fixture receives its power. They call it power connection box. So what's this? What's the function of this one? Circuiting. Why do we have a power box? In order to properly circuit it based on an DC code book. Any comments, guys, about the housing, the lamp, the ballast, and the power connection? Common sense, right? Right above your head, common sense. Any comments, Karen? Any comments, any questions? The last two that I'm going to focus on, guys, are directly related to the science of lighting. Everything else so far, this is protection, this is creating light, this is maintaining the light. In order for the light to work, you need a ballast or a driver. This one is to power that light. The last two, which is reflector and diffuser, has to do with the lighting science. So for example, reflectors, guys, inside, take this, the luminaire, your luminaire right there, they put the lamp right underneath it, and they have a very shiny surface right above it. The reason, because when you put a lamp right there, guys, do you want to lit above the suspended ceiling, or do you want to lit the floor? Of course, we want all the light to shoot all the way down to the floor. So the smarter than Chad said, well, here's your source of power, right? Inside the fixture, you have a very shiny surface here, and we curve it, so the light will shoot down, great, and whatever shoots up will bounce off these shiny surfaces and reflect it directly down. So what does the reflector do for a living? It directs all the light to where you want the light to go. Most of the time down to the working 2.5 Remember that 2.5 foot calculation zone? Your lighting, your reflector, guys, is supposed to reflect all the lights directly to the calculation zone. So you can get the best performance out of your lighting fixture. The best lumens, the maximum amount of lumens, the maximum amount of foot candle. Can I have a thumbs up, Chad? We understand what a reflector is. Good. Yes, Karen? It reflects all the light, bounce them all the way down. Without reflector, your fixture will be inefficient because most of the light shoot all the way up to this base. So what do I need to go lit? I want to lit this area, not lit above the suspended ceiling. Okay, that's my reflector. Now what the heck is a diffuser and louvers? You're looking at them, you're looking at a diffuser right here above your head. So now we have a reflector, which typically a shiny metallic surface, curved, parabolic shape. Most of these 2x4 or 4x4 reflect the lights. Then we need, now we reflected the lights, now we read something called diffuser or louver. Now all of them have diffuser or louver. If you guys, and Gary Ryman, God bless his heart, he always used to go, was he with you when he took all these diffusers down because it gives you more light? If you take these are diffusers. You take them down, it gives you more light. The job of the diffuser, guys, is to evenly distribute the foot candle over the area. Evenly distribute. Why? Because I can see you. It makes it easier for the eye to see. No stress on the eyes when people are working. It makes it basically a better place to work and perform. So diffusers, you're looking at it right here. Louvers are these squares, guys. You've seen them all the time in the fixtures. They're squares, or they're basically squares, and they take the light and diffuse it or disturb it to make the surface evenly lit. So the smarter than Chad take the reflectors to reflect most of the light. Then after they reflect it, now we don't want to reflect it, focus it. We're not talking about spotlight. We're going to evenly distribute it. Then they put, can you guys see that? The what do you call this one? Diffuser or louver. In order to evenly distribute the light. So you can get do you guys remember the maximum to minimum, average to minimum? When Andrew was here, he said a perfect lighting system, when you guys are going to be doing calculation, the max to minimum should be 1. So meaning the brightest spot in your room and the darkest spot in your room is the same. Now that's ideally, you almost have to do LEDs to get that very close to this, 1-to-1. So if you're not using LEDs, guys, or even if you're using LEDs, in order to achieve a close to 1-to-1 distribution of your lighting system, you have to use something called louver or diffuser. Any comments, guys, about these 6 things, this 6 part of a luminaire, and what do they do for a living? Everybody understand that? These are what the chapter talks about, these 6 things of a luminaire. What do they do for a living? The diffusers and the louvers also have another function, guys. We say distribute light evenly. Both of them, they distribute light evenly, and also they cut on the glare. Now, if you, whenever, Matt, you become a certified lighting designer, you're going to be paying attention not only to the average foot candle, not only to the evenly distribution of light in your building, but also to the glare. How many of you guys looked at the sun and your eyes got really irritated? Anybody tried that one when you were kids? Try it. Look directly into the sun. You're not supposed to. It hurts your eyes like hell, right? Same thing. If you keep looking at these bulbs here, if I take that diffuser, guys, Kieran, if I take that diffuser and ask you to stare at that lighting fixture for 5 minutes, it will hurt your eyes. That's called the glare. So the diffusers, guys, diffuser and louver is supposed to hide the lamps. Every time you hide the lamps, look at this lamp. Every time you hide the lamps, you cut on the glare. You cut on the glare. What does that mean? It means that people feel better. They're not looking at very shiny object. You diffuse it. So the diffusers also not only distribute the light and the louvers, but also they hide the lamps in order to cut on the glare. The glare is very uncomfortable feeling when you look at a lighting source. That's give you a very uncomfortable feeling. Okay, so that's your glare. Hide the lamp in order to get you the glare. There's something called coefficient of utilization. See you guys, we're going to use it next, not tomorrow, the day after. Coefficient of utilization, the reflector and the diffuser and the housing will decide what's the coefficient of utilization of that fixture. So what the heck is that? Coefficient of utilization of a fixture, guys, is how efficient the fixture is. You put a source of light right here. How much of this source of light actually going to where you want it to go, and instead of going all over? They call it coefficient of utilization. It's a function of the fixture structure itself as well as the surrounding, the walls and the ceiling and what's not. So anyway, keep in mind the housing, reflector, and diffusers also decide the coefficient of utilization to the fixture. The higher the coefficient of utilization, the better the fixture will be. The better the fixture will be. Meaning it gives you a lot of light for less amount of watts. Any comments, guys, about these? Any comments about this one? This slide? Any comments about this slide? So these are your luminaires, and each one of these parts of a luminaire, and what does it do for living? What does it do for living? Comments, questions? Does it make sense though? You guys are going to be dealing with a lot of luminaires, and when you're dealing with luminaires, ask yourself, where are these 6 things in this luminaire? Some of them might not have 6 things. If you go to a round light, guys, it might not have a diffuser. You know, this is a typical luminaire, has all these things. Some of them might not have diffusers or louvers. Almost all of them have, they have to have housing, they have to have reflector, they have to have a lamp, they have to have a driver, ballast, and power connection. But diffusers and louvers, smaller fixture might not have a diffuser or louver. Okay, so that's my lighting source. Any comments, guys, about the luminaires before we go throwing luminaires into a building and talk about how to use them? Any comments about that one? Comments, questions? The second thing that comes into the luminaires is application of these luminaires. Now we know what the luminaire is. What does it do for living? What are the major 6 parts of this luminaire? And what does every one of them do for living? Now, we're going to put these luminaires in action. We're going to put them in buildings. They pay us, Adam, to put luminaires in buildings. That's what they pay you, and receptacles and what's not. So when you put them in building, the first thing you need to come to your mind, guys, is, number 1, application. Is it inside dry or is it outside wet? These are the things that comes to your mind when the application of the fixture. Where are you going to install these fixtures? Are you going to be putting it inside where it's a dry location mostly, or outside if it's wet location? So if this fixture above your head, guys, is supposed to go in the parking lot, it has to be listed for wet location, right? Has to be listed for wet location. So the most important thing whenever you pick a fixture, always the decisive factor, is it going to be indoor or outdoor? Is it going to be wet location or dry location? Because the fixture have to be rated for dry location. Okay, comments, question, guys, about the app when you for application fixtures, like everything else. The question number 1 is it dry or wet location? Because the fixture have to be, if it's wet location, it has to be rated for this. Okay, next, hazardous locations. How about, am I putting this fixture in a gas station? Am I putting it in a chemical plant? So every time you turn the light, the bulb is going to get hot and ignite the surrounding, and big ball of fire engulf that chemical plant. Do you guys see that all the time, huh? If you don't pay attention to that one. So the second thing, so I know dry or wet, great. Then hazardous location. Hazardous location, guys, is a class 1, div 1 and div 2, and class 2, div 1 and div 2, and class 3, div 1 and div 2. Now what the heck is a class 1? Class 1 is flammable gases, gas stations, petroleum manufacturing plants. Do you want to put this fixture in a gas station? Class 1, div 1, flammable gases. Div 1, hazard exists at all time. Div 2, under abnormal condition, you get the hazard. Yes, then this fixture have to be rated for class 1, div 1. They call them explosion proof. Cool? Check. Then, class 2, guys, flammable gases, combustible dust. Are you going to put it in a place where you have combustible dust? Right? Combustible dust. Are you going to put it in a place where you call it combustible dust? That's class 2 location. Div 1, the hazard exists at all time. Div 2, under abnormal condition, if malfunction, it will ignite the surrounding. If you have a combustible dust in the area, chemical plant, they have certain combustible dust, metallic or non-metallic, that could ignite, your fixture must be labeled for combustible dust. Gentlemen, we'll focus more into these locations. Please hold your horses, Derek. Next project is going to be industrial. We'll talk in details about these locations. For the time being, flammable gases, class 1, has to be labeled for class 1, div 1 or div 2, as well as the group, also the group of the gas. class 2 combustible dust, as well as the group of the dust. And ignitable fibers is class 3. This is called class 3, guys. Ignitable fibers, um, or anything they manufacture clothes and what's not. They can have things that could be fibers that could be ignited. If your fixture is that type, also it has to be rated for that location. Okay. Any comments, guys, about the application of fixture? Most of them are dry, Adam, so no problem. Go ahead and put them in dry location. If it's wet, make sure it's wet location. If you're in any of these hazardous location, make sure your fixture are rated, listed for these hazardous location. Either explosion proof or dust tight, or dust, they have a term explosion proof fixture, or dust tight fixture, or dust ignition proof fixture in a class 2 location. Any comments, guys, about inside, outside, and hazardous location? Does it make sense? Does it make sense? Yes, no, Brian? Is it Monday? The juice is not going yet. We'll get the juice. Did you drink your coffee? Okay, now we got into inside, outside, hazardous location. Then voltage. When you were dropping fixture, when you guys are dropping fixture with Chad, you're going to drop a fixture in families. You're going to see 277 or 120. I have students, guys, drop the fixture 277 and they're trying to wire a fixture 277 from a 120 lighting panel. It wouldn't work. You can't wire a fixture that rated for 120 from a 277 panel or vice versa. For fixtures, guys, here's your option. Your option, a lot of people take, when you guys pick a fixture, you're going to have a voltage, multi-voltage. If you see the word multi-voltage, this means bring it on. Bring a 120, 208, 277, 480, 600, most of the time. Any voltages, bring it on, okay? So that's called multi-voltage fixtures. Now, it's an option that you can, an option with the ballast. When you pick the ballast, guys, it tells you what type of voltage you want. Obviously, what's wrong with multi-voltage? Spendy, you're going to spend more money. If you know what your voltage system is, from the get-go, when you pick your light fixture catalog, I'll show you in a second, you pick 120, the most common one, or 208, 2 phases. You can 2 phases coming to the fixture, or 277, 1 phase to neutral, or 480, 2 phases from 480 coming, or 600 like in tunnels and what's not. Typically what we use in a commercial building, what you're allowed to use in a commercial building is 120 or 277 or 208. If you are to go 480, there's restrictions on how high the fixture is. Parking lot becomes parking lot. If you go 480, guys, and 600 volt burning the fixture, you're talking about parking lot lights or tunnels. You know what I mean? Outside lights. Okay, so there are 2 options, 120 or 277 in a commercial industrial building. That's my light. The second thing, guys, is the watts of the fixture. How much watts do you need out of this fixture? Remember, there's something called energy code that we adhere to. You guys are going to do energy code calculation for Chad, so you can't just pick any fixture with any watt. You know, you have to have the efficient fixture, which can give you a lot of lumens with little amount of watts. So you can go from 5 watts all the way, and I threw these numbers, guys, to 3,000 watts. There's big fixtures, floodlights that can consume a lot of power. Lumens. The lumens, Adam, lumens, the amount of light that the lighting source can get you, you can go from 3,000 lumens, even less than that, to 6,000 lumens. So you can have a 3,000 lumen lamp, or a 6,000 lumen lamp, or 4,000 lumen lamps, and what's not. So these are the factors that you're going to take into consideration when you apply your fixture. We're in Minnesota. There's something called temperature. Karen was just warning us from the storm that's coming soon. So when you have a fixture, there's ambient temperature, guys. There's an ambient temperature that you have to adhere to. So that's also, if you want to put a fixture in outdoor in Minnesota, it has to be rated for a lower. So we have minus 20 Celsius all the way to 50 degrees Celsius. A lot of fixtures, guys, they give you a range of temperatures that they can work on, from minus 20 Celsius, that's cold, into minus 50 Celsius, that's very hot. So they give you a range. When would they perform within that range? If it's outside that range, Derek, you have to talk to the manufacturer for your fixtures. Okay, so that's my temperature. There's something called VCP. Anybody knows what a VCP is? For every fixture, there's called VCP. VCP stands for visual comfort probability. You know what they do with this, Karen? They bring how many of you guys? There's 5 of you sitting right underneath this lighting fixture. They sit you there, let's just say for an hour, performing a task, and then they survey you. They say, okay, Karen, how do you feel about the lighting in this room? And then you rate from 1 to 100. You rate that lighting fixture, and you rate, all of them will rate it. And based on the rating of the people, they give that fixture a visual comfort probability. So what does that mean? Meaning the people feel good underneath this fixture. Did you guys hear me? So if you have, it can go from 0, very uncomfortable, into 100% very comfortable underneath these fixtures. Did you guys hear me? So who decided that one? The manufacturers, and based on the housing and the louvers and so they make certain fixture can make people feel comfortable in a room, others would not. So of course, if you're doing a fixture, you need to be in the comfortable zone, not in the uncomfortable zone. Can I have thumbs up, Chad? We know the visual comfort probability. And Adam, my friend, he will be on the test too, that visual comfort probability. What is a VCP means? That's a measure of how comfortable the people feel underneath this lighting fixture working, right? So of course you need your fixture to be very high on this VCP factor, not 0. It's going to be in the 90s and what's not. Okay, so that's the comfort. So how do you make it comfortable? We talked about this one, guys. Hide the lamp, because when you hide the lamp, people don't raise your hand and looking at a bulb that makes you feel uncomfortable. One method of making people comfortable under a lamp is to have diffusers. Hide the lamp. If you can see all these spotlight guys, what do? They don't make them stick out, right? They're always hiding in. Have you ever wondered why they don't make them? Most of them are not sticking out. They're hiding in. If they stick out, you see the lamp. If you look at the lamp, it makes you very uncomfortable. You're not supposed to be looking at the lamp, but so if you hide it in a hole, you really have to be right underneath it to see it. But if you're standing right here and looking at the fixture, you can't see it unless you go underneath it. How many of us go right underneath the fixture and start looking at the bulb? Very few. But if I'm standing right here, I'm looking at the ceiling. If the bulb is out, I can see it. Anyway, so that's your visual comfort probability level. Visual comfort probability level. The last thing I will talk about, guys, is this is mounting, believe it or not. The last thing is, how do you mount the fixture? How do you mount the fixture? Look at it right here. Recessed. Either recess it, exactly like this. You're looking at it. Surface mounted, right? You just either in the wall or on the wall. Recessed in the wall, on the wall. It's going to be surface mounted. Or you can hang that fixture. In a few seconds here, when I'm done, we're going to go to the open office. In the open office, the requirement is to hang the lighting fixture. So here's the ceiling. We're going to have a stem like this, and we're going to put my lighting fixture right underneath it, and it's going to be direct, indirect light. Shoots light up and down, up and down. That's the lighting fixture that we're going to be used in the open office. So that's called you hang your fixture typically 2 to 3 feet off the ceiling. So that's you hang your surface. So we have recessed, we either recessed it, surface mounted, or hung. These are the options that you're going to have for your fixtures. Pole mounted, of course, if it's outside. Wall mounted, pole mounted, wall mounted, or ceiling mounted. Right? These are another. How do you mount it? You can have it recessed in the ceiling or on the wall. Any comments, guys, about mounting a fixture? Typically, a lot of stuff is recessed. We don't like to use surface mounted in the commercial industrial, guys. Recessed, but a lot of places are using hung lighting fixture because it gives you direct and indirect light. You put your fixture right here, it shoots light at the top, light at down. It makes people feel really comfortable right underneath. Remember that comfort probability level? If it's direct and indirect light is the buzz now, or has been for a while. So if a lot of you go to offices and you see that lighting fixture is lower, a foot or 2 feet probably lower than the ceiling, it shoots, and direct and indirect, you don't see the lamp. The lamps are either completely direct, where they shoot the light off to the ceiling, bounce it down, or direct and indirect, there's holes here, where the light will seep right through the holes, as well as shoots up and bounce down. Any comments, guys? Any questions? Questions about the application of lighting fixtures? These are the most important thing in terms of application. I put this one, guys, for you in terms of, here's a way of connecting your 3 parking lot lighting fixture in a 3-phase system. You can you can take a three-phase system. Look at that. This 48 three-phase system into a parking lot light high. They have to be a 30-foot to 33-foot lighting fixture. And you can bring at two phases. If you go in the parking lot, Adam, when you guys start doing parking lot, you can burn your parking lot at the higher voltage. What? Anybody wonder why do we like higher voltage in parking lot? Did you guys hear about something called voltage drop? The higher the voltage, the best in terms of outdoor. Why don't we care about the higher voltage indoor? Distances are small, they're short. So if you go outside, you could be in a situation where you have a light 1, light 2, light 3. Here's light 1, light 2, light 3. Big lighting fixture. You take to them three phase, and connect them between phase to phase, phase to phase, phase to phase, no neutral, and you shoot these and you burn them at 480. Now the ballast have to be rated for 480, no neutral, and you have to also simultaneously disconnect them. So the smarter than Chad guys will put a contactor here on each one of these. And these are welcome to something called lighting contactors. That's exactly what you guys did with us in the lab, the ones who were electricians. We have a contactor, slam, open, shut. Instead of starting an air handling unit, now you're starting and stopping multiple fixtures. Parking lot. Any comments, any questions, guys, about the application of fixtures? Application of fixtures, comments, questions? So please read this book or this chapter. Talk about reflectors. The last thing I want to talk about, any comments about, so we talked about the luminaire, what luminaire is, what the application of a luminaire. Now let's talk a little bit about the science that you guys are going to be doing. This is isofoot candle. You guys in a few seconds, you will be doing this one with visual lighting calculation. Let me show you what this, you'll see this one all the time. It's called illustration of isofoot candle. The curve, these curves, the blue curves, I call the isofoot candle curves. Can you guys see them? Let me walk you through this. I have a parking lot fixture, metal halide. It's sitting at 30 foot. I'm mounting that baby at 30 foot in the parking lot, floodlight, and I'm measuring the distance between 30 feet away from where it's mounted in every direction. Can you guys see that? Imagine the lighting fixture is sitting right here. And it's a 30 foot, so you're measuring 30 feet, 30 feet, 30 feet, 30 feet around it. And it's shooting light all over. Imagine. Now you can direct the light to go this way or that way, right? You can direct it. Typically you direct it, okay? Now here's my light fixture. I'm going to direct my light to go this way because this is the neighbor. I'm going to sue me if I shoot light into his bedroom while he's sleeping. So these are the 90% cutoff on what's not. So they put a reflector so it reflects all the light this way. So imagine, here's what you're looking. Here's my parking lot, 30 feet, 30 feet, 30 foot high, okay? And we're shooting light and we're directing it. Now, these lines, now this one here, guys, is, they call it the mounting height. The mounting, they call it distance to mounting height ratio, distance to mounting height ratio. So when you see 1, or minus 1, plus 1 or minus 1 here, it means this point here is 30 feet away from the fixture, and this point is 30 feet, this direction for the fixture. This point is 60 feet, 90 feet, and this will be 120 feet. Same thing, this is 30 feet, 60 feet, 90 feet, 120 feet. You see that? In multiples of 30. Why 30? Because the height of the fixture that we're using here is 30. Could be 10. Did you guys hear me? Everybody see that? Now the smarter than Chad goes, the manufacturer of the fixture guys, they go with a foot candle meters and they measure sensors, literally. They put sensors all over here and they measure the lumens at each and every one of these points. Literally, they have a sensors. We went to Hall of Fame lighting in Ohio 6-7 years ago, Gary and I, and they showed us a room probably 3 times bigger than this room, and they put the fixtures in one corner and they have sensors all over and they shine that fixture and it senses and measures all these lumens. That's how they come up with so-called isofoot candle curves, the isofoot candle curve. So isofoot candle curve, guys, is the curve that connects, so it's a curve that connects all the points that have the same foot candle, So for example, if this curve right here have 5-foot candle, connects all the points that have a 5-foot candle. This one, 2.5 it looks like. This is 0.5, this is 0.25. So they draw curves around the fixture to connect all the points in the system that has the same foot candle. Do you guys remember when Andrew came and he grabbed a fixture with curves like these, and it has there's isofoot candle curves for them. It tells you it's easy to lay them out. That's what you're doing. You're picking the isofoot candle for all these curves. The isofoot candle for these curves. Okay, any comments, any questions about the isofoot candle? Everybody understand what an isofoot candle is? It's a curve that connects all the points that has the same foot candle around a fixture, around the fixture. Any comments, guys? Any questions? Comments, questions? So that would be your foot candle. Let me. Now this photometric characteristic curve, then that will lead you guys into the photometric characteristic curves, and in page 31, 32, 33, they talk about the photometric characteristic curve. So, like I said, Derek, they put your fixture here. That's called photometric characteristic curve. Every fixture comes with a curve like this. Thanks God to Visual and all the other softwares that we use. Otherwise, they used to do the calculation by hand long time ago, guys. Now, every fixture that you pick, it's going to have a curve like this that gets you the distribution, how many lumens at every angle away from that fixture. For example, here's my 90, 270, 0, 180. This is a fixture. Matthews is shooting the light this way. And then they take at every angle. Can you guys 15? At the 15 angle right from the vertical, I have 805 lumens. 805 lumens. At 30, at 45, I have 1,203 lumens. So they measure the lumens right around the fixture at different angles and distances from the fixture. So the lumens at different angles around the fixture, ladies and gentlemen, is called photometric characteristic curve. Photometric characteristic curve. Photometric characteristic curve. You got to know that, because guess what? We'll be testing on it, guys, next week. I'm going to be giving you a curve with a table, and it will tell you at this angle you will have this amount of lumens. So it'll tell you that at certain distances, at different angles, you will have the certain amount of lumens coming out of that fixture. So could you please do me a favor? Can you guys go to page 33? Everybody who has a book, page 33. Page 33. If you guys go to page 33, in the upper left corner, it will tell you, Derek, it will tell you, see where the angle is? Can you guys see you see guys that curve here? Same curve that we're looking at, except half of it. They're just showing half. You know what why they show half? It's symmetrical. The other half doesn't give you anything. It's all symmetrical, right? So because it's symmetrical, they typically show half, 1/4, or 1/2 of it, because the other one is symmetrical. Okay, so look at this. At angle 0, right underneath the fixture, I have candela power, which is lumens. I have 650. At angle 5, you can see where 5 is. Can you guys see where 5 is right here? See where 5 is? Angle 5, I have 661. At angle 15, 800. At angle 25, 830. At angle, the largest amount that you get, guys, is at angle, it looks like, at angle 65. Can you guys see that? At angle 65, when you are 65 away from, here's the fixture here. I'm right here. Can you guys see that? Here's my fixture. I'm going to move 65. I'm at this point here, and the fixture is shining right at me. That's the largest amount of lumens that you're going to get out of that particular fixture, and it looks like you're going to get 3,675 lumens. After that, guys, 75, start going, now you start rotating, start getting less and less and less lumens, all the way until you reach 135 degree, and it will get you 220 lumens. Ladies and gentlemen, welcome to the science of foot candle calculation and lumens. That's how they do it. I was shocked, Derek, when I went to this tour. I thought, a lighting fixture, what the heck is a light? It's just a lighting fixture. Unreal. It's science behind it. The optical that they do, the lenses that they use to direct the light, it's unreal. They use scientists, guys, to design certain lenses to direct the current, not the current, they direct the light in certain areas to get you the better performance of that fixture. So it's a lot of science involved in it. For your 1 second mind, since you guys are designers to start with until you become lighting designers one day, we're going to just touch the surface. So what you're showing here is touching the surface. So they take the manufacturers, have a fixture in a room like this with angle sensors at every angle, and they sense how much foot candle will be reflected out of every single one of these fixtures. And every time they change the reflector, they do another different calculation. If they every time they change the type of the fixture, the housing, a third calculation, because all these lumens, guys, are a function of the lamp, reflectors, louvers, lenses, what's not, type of lamps too. So every lamp with every fixture, louver, all the components of it will have its own curve. Any comments, guys? Any questions? Any comments? Any questions? This happened to be for 150 watt high pressure sodium, that distribution. Every single fixture will have a curve that's called photometric characteristic curve. They're very handy when we're doing it outside, guys, for the parking lot, because with isometric and photometric characteristic curve, they're very handy because it gives you the best performance of the lighting fixture. Any comments, guys, about photometric characteristic curve? Every fixture will have one of them. Every fixture will have one of them. Any comments? Any questions? Any comments? Any questions? The last thing I want to show you guys is I don't have a picture of it, but I would like you guys to go to page, please. Page 34. Go to page 34. Page 34. Page 34, guys. The last thing in page 34, it has lighting distribution from a lighting fixture. It's so important, guys, to know that one, because when you're picking up the lights for your friend Chad, you're going to hear the following terms. And if you are to get into the lighting business, you don't understand it, you're out. You're not in the game even. Number one, you're going to see direct light. Karen, a direct light is light above your head. And look at direct light, it shoots up to 10% up and down 90% to 100. So Matthew, you can look at how the bulb is, that little curve here. Can you guys see that? It's shooting all the lights down. That's called direct light. A lot of the cheapest piece of fixture, 2x4 troffer or 4x4, guys, that you're going to buy, surface mounted, Brian, or recessed, it's going to be called direct light. Can I have thumbs up, Chad? Direct light will shoot most of its light up to 90 to 100% down. Going up is 0. That's exactly like that fixture. Okay, let's go to the second one. The most common is direct and direct light. Okay, now this is semi-direct. Can you guys see the semi-direct one? The next one? Look at this baby here. Semi-direct. That guy can shoot up to 40% up and down up to 60 to 90%. In order to have a semi-direct, guys, you have to suspend the fixture. You can't have semi-direct without suspending a fixture. So in order to get into semi-direct, you have to put your fixture like this, Karen. Here's my fixture, suspended. Now it's shooting some of the light up, reflects of the ceiling, bounce back. Look at this. The light is going up, some of it 40% up, shoots back, and 60% will go directly down. Any comments, guys, about semi-direct? Everybody can see. The only difference is the percentage. So up to 40% can be going up, and up to 90% can be like 40-60, depending on the range that you're going to cut it off. Go up 40%, 60% down. Now let's go to, guys, general diffusers. Can you guys see general diffusers up to 40 to 60% down? So general diffusers, can you guys see how it looks like? So imagine when you walk, guys, in here at Dunwoody, you can see a lighting fixture that reflects the light all over in every direction, up and down and everywhere. Typically, you will see a pole like this with a bulb right at the top of it. Now the light is going all over, up, down, and in between. Outside fixtures. That's called general diffusers. The most important one is direct, indirect. Can you guys see the one that says direct, indirect? That's the one that we need to use in the open office. In the open office, you are required to have direct, indirect light. What does it do for a living? It can shoot up to basically 50-50. You can put 50% of the lumens shoot up to the ceiling. And of course, when you go to the ceiling, now you lit the ceiling will bounce off the ceiling, go down to the floor. Okay, so 40, almost 40 to 60, 40 to 60, up and down. Everybody understand direct and indirect light, guys? They have to have holes. What they do, they have a lamp like this with holes here. The lamp is sitting here, it shoots light through the holes and also bounce all the way out. Okay, now the last one is semi-indirect. Can you guys see where it says semi-indirect instead of semi-direct? Semi-indirect, it shoots 90% of the light up and just a couple of holes in the bottom that shoots, say, what is it? They have up to, say, 40%, 10 to 40% down. So most of the light will be shooting up. And the last one, which a lot of architects love, guys, it's called indirect light. Can you guys see the image? Indirect light, that baby, the bottom is solid, and you put the bulb right here, suspended, and all the light that comes out of that bulb is shooting to the ceiling, bounce off the ceiling down to the floor. Any comments, any questions about these types of fixtures? Direct, indirect, semi-direct, semi-indirect, diffusers. These are the terminology they're going to use. Most of the common ones they're going to use, guys, is either direct lights, like this above your head in our project. Almost all of them are going to be, guys, direct, or direct, indirect. We're using direct, indirect in this project, direct, indirect. Some goes up, some goes down. I don't think we're not using anything completely indirect. Which one is the most expensive and the better performance, guys, right now? Indirect light. Indirect light, they're beautiful. They make the room. Look at can you guys see that the ceiling here is dark? Look at the ceiling. Do you see that the ceiling is dark compared to the walls? That's the direct light. It gives you a dark ceiling compared to the walls and the floors. Now, who cares if you're Matthew or Chad? As long as I can see Chad, I don't care. If you get into an architectural office, guys, with interior design, ladies and gentlemen designing it, you can make a room that's well designed, interior, and well architects, done well as an architect, and you put a lighting fixture that make the room is socks. So lighting becomes a major part of the interior design of a building. We have an interior design program here. The ladies there and the gentlemen, they are doing lighting calculation, guys, like you do, because the fixture can make the room looks good, bad, or ugly, the type of the fixture that you choose. So I want you to understand the gravity of this lighting system. It's a major thing. You have to pick. So if you pick indirect light, typically, what's wrong with indirect light, guys? It's expensive. Because now your fixture cannot be very efficient because it has to shoot the light up. Now, depending on what type of ceiling, if you have a black ceiling, don't think you're going to get a whole lot reflected out of black ceiling. So if you have an indirect fixture, now most likely the architects, if you specify indirect fixture, the ceiling will be some type of a light color ceiling, so it can reflect most of the light. Any comments, any questions, guys, about direct, indirect, the distribution of light? They call them the light distribution patterns. Any comments, any questions? Karen, does it make sense? Please read this chapter. There's a lot. So we talked about, guys, what a luminaire is. How do you apply a luminaire in a space? And we talked about photometric characteristics for the different type of fixture and the distribution pattern for these luminaires. And we emphasize the indirect one and direct, indirect, because we're going to be using them in our project. Any comments, any questions? Any comments, any questions? Comments, questions? Okay, so what I'm going to have, guys, I'm going to give you 5 minutes, and then we're going to go to visual. And we're going to build a room in visual. I would like you guys to follow up with me. We're going to build the open office. We do the solid. We're going to do a calculation zone at 2.5 feet. And we're going to drop a couple of fixture and do calculation in the open office. Why did I pick up the open office? Because probably it's the hardest one. The ceiling is high, different, and suspended light in it. Cool? Shall we? Okay, let's take 10 minutes, 5 to 10 minutes. Thank you.